Hello guys. Today I am with Hussein. I have a problem for Hussein to solve about the concept of integration and differentiation. Hello Hussein, how are you doing today?
Hi Amir, hi everybody. I'm good, thank you.
Yes, you will be actually excited about the problem, I'm sure.
Yeah, yay.
So, yeah, as you can see, we have a curve here, a function in orange. And so I read the problem for you. Let g of x is equal to integral of f of t dt from 0 to x when x is positive. So given that a part of the problem, find local maximum and minimum of g of x. In part B, find absolute maximum of g. And then in part C, find the intervals that G is concave down.
Okay.
So,
all right. And what is this
let's
curve?
start.
Is this a curve of F or G?
This is a curve of F.
Okay. Let me write it down
Yeah.
here. So this is F of T and this is the T axis.
Yes, yeah.
Okay.
This is curve of F. That's very good point. And then you have the curve of F, and given that integral above the figure, you're supposed to solve part A, B, and C.
Okay.
So let's start with part A. Please find local maximum and minimum of g of x.
Okay. The local maximum and minimum. So let me just at the beginning just draw a hypothetical curve representing function g. So assuming this is g of x, and maximum happen when so this is a max. This is g
so
of
if you could please
x.
write down the axis g and x.
Okay.
So
yeah.
it can be clear. Yeah.
So let's assume this is this is g of x and this is x-axis, and then the maximum happen when the slope of g of x change from a positive slope to a negative slope. And
so
then,
yeah, it's g prime. Yeah, g prime is positive.
Yeah, so a slope, we know that a slope of tangent is the same as the first derivative. And so in the first branch, the g prime of x is greater than 0. And then the second branch downward, g prime of x is less than 0, is negative. And then minimum happen when the slope changes from negative to positive. So this side is positive. It means that g prime of x is greater than 0.
And we know that g prime is equal to f.
G here defined as an integral of f of t, and from the fundamental theory of calculus, we know this: if g of x is equal to integral of a to x, from a to x, f of t dt, then g prime of x is equal to f of x.
That's fundamental theorem of calculus.
Yes, that is fundamental theorem of calculus, and obviously both f and g need to be continuous.
In the interval.
in the interval from A to X. And
yes, continuous and differentiable. Yeah.
And differentiable. Yes, that's correct. And so knowing these two things, first, where the maximum and minimum happen, and second, the fundamental theorem of calculus, I think we can tackle the first part of the problem, the local max and mean of G. So let me go back to the curve here, f of t. So this f of t is actually g prime of x.
Yeah.
So we're looking at g prime of x.
Yeah, going back down to the aside that you have, please use a different color and write down next to g prime like f. For example, f greater than 0, f greater less than 0. Yeah.
Yeah. So this area, when g prime of x greater than 0 means f of x greater than 0, and then here f of x less than 0, and here again f of x greater than 0.
Great. So when we look at the top curve, we just need to look at the sign of f, above x-axis or t-axis and below the t-axis. So whenever f of t is positive, when it changes the sign to negative, we know that, okay, it's going to be a maximum, a local maximum, something like that.
Right.
So that's very easy.
So for example, at this point here, so above the t-axis, f of t is positive, and then below f of t is negative. So this is one of the point that we the slope of g changes from positive to negative, and then so based on what we saw here, when the slope changed from positive to negative, then we have a maximum.
Correct.
So I can say this is a max. So it means I have something like this. And then next point is here. And the slope changes from negative to positive.
Yes.
So going down here, so when the slope changes from negative to positive, I have a mean.
It's a local minimum. Yeah.
Local minimum. So this point is a local mean. It means that I have the curve of G is something like that.
Correct.
And then moving forward, the next intersection is here. And then the slope changes from positive to negative. And then as a result, exactly, I have a maximum here. And then next
the curve
point,
the small curve that you are showing belongs to G. Actually.
Exactly. Yeah, G of x. And then, so this point, a slope changes from negative to positive. So I have a mean.
Yes. Yeah, that's a local minimum.
And then next point, again, from positive to negative, and I have a max. And so on.
And so on. Yeah, wherever you have an intersection with t-axis, with the horizontal axis, that's the point of interest. And
right, it's either local mean or local max, and then we need to see if we're going from positive to negative or negative to positive.
Yes, yeah.
Yeah, I think that answered the first part.
Yeah, that's the first part. For the rest of the problem, I think we are running out of time.
Okay.
So I'm going to stop you here, Hussein. I believe we can solve the rest of the problem in the next video.
Okay.
Yeah, next week. So yeah, for the first part, we explained that, okay, based on the the slope of the curve, either it is positive or negative, and also looking at the fundamental theorem of calculus, we can obtain, we can look at the curve of g of x, and we can proceed with the solution for finding local minimum or maximum, and that's actually the application of the integral and differentiation. So that's the illustration of that, and I think that's a good problem to address.
Yes.
So thank you very much, Hussein. Yeah, for that.
Thank you.
And for the viewers, hope that you actually learned something from this video, and if you like this one, please like the video and hit the subscribe button. And until the next video, cheers and stay safe. Thank you.
All right. Bye, everyone.